Hello everyone, this is Matt Rogers from Salisbury Elementary School. Today we're here to talk about Unit 2, Lesson 16. We spent some time so far looking at 1-digit by 1-digit multiplication, 2-digit by 1-digit, 3-digit by 1-digit, 2-digit by 2-digit, and now we're going to do 1-digit by 4-digit. We're going to multiply to the thousands place. What's convenient for this lesson is it's almost practically identical to everything we've done previously. Process-wise, using your facts, it's just 1 digit more to work with. In class we talked about it really being the structure or the organization is really the only difference. When we look at this first picture, what we have is our area model, and in this case the area model, instead of representing 100 blocks or quick tens, each of these individual areas are 1,000 spots or areas, blocks, as opposed to hundreds. And that's noted at the top. When I have 3,000, I break it into 3 groups of 1,000, and then along the side I have it by 7. So each of these blocks is 1,000. If I were to count up 3,000 by 7, or 21 of these boxes, I would get a total of 21,000. So, the one thing we talked about in class is, at minimum, this first question is, how many zeros can I expect? And in this case, when I talk about zeros, I can expect at least 3, and that's because I have, in 3,000, I'm going to have 3 zeros after that digit that I'm going to add to the end of our basic multiplication problem. In this case, it would be the 7 times 3, as shown right here, and then you add these 3 zeros to the end product. So when I have 21 and 1,000, I take these 3 zeros and add them to the end, which makes it 21,000. We did talk about certain problems such as 5,000 times 8. Well, in that case, when I do 5 times 8, it's going to be 40. So I'm going to have a 0 from the 40 and then the 3 zeros. So at minimum, our number of zeros will be 3. Okay, so that is one thing that we talked about. Number 2 talks about how, when thinking of 3,000 as 3 times 1,000, how does it help you multiply 7 by 3,000? Well, by thinking of it as 3 times 1,000, I can break it up as our multiplication and do the 3 times the 7, and then just multiply the 1,000 afterwards. So, I know 3 times 7, that's pretty easy. We've been doing that problem for a while. And then I add the 3 zeros to the end, and that gets our overall answer. For this area model, fairly simple. I'm just going to do the area sketch model, and it's by no means perfect, as you can tell. So along the side, I'm going to have 4. And I would draw 4 boxes, or excuse me, rows. And then I'm going to have 8,000, and I'm going to do 8 columns of 1,000. So each one of these would be 1,000. So you get the idea. So then each individual would be 1,000. I count up the number of blocks, and I get my answer. Or I could do 8 times 4, which gives me 32, and add the 3 zeros to the end. 1, 2, 3 gives me a total product of 32,000. We also looked at some of our other methods that we've been using with our multiplication. In this case, we have the area sketch model up at the top, where I would have the 8 times 3,000. I would then have 8 times 200, 8 times 40, and 8 times 8. That would give me our 4 partial product equations. When I solve them, I would get the answers as shown here. So the place value method you see here, each of those individual problems, 8 by 3,000 is 24,000, 8 by 200 is 1,600, 8 by 40 is 320, and then 8 by 8 is 64. Gives a total answer of 25,984. And you'll see these are identical to the same processes that we took when we were doing 2 by 2 digit, 1 by 3 digit, 1 by 2 digit. Same process, just with one more step with the thousands place instead of the hundreds, tens, and ones. On this page, we really spent some time just practicing some of our equations. They were required to draw the area model and then solve the problem how they wanted. We have been talking a whole lot about choosing the methods that are most comfortable for us. So that's what we've been focusing on, and the students have been identifying. If they are most comfortable with expanded notation, use expanded notation. If they're comfortable with algebraic, use algebraic. If they're only comfortable with place value, stick with that place value method. For the most part, that's all that we covered today in 2-16. If you have any questions, please let me know.